Day 121, Honors Physics, Ray Tracing, example number 2. This is the same mirror we had in example number 1. And once again, we want to locate where the image would be given the conditions. We have a converging mirror. Once again, we're working from left to right. It says the radius of curvature is 40 centimeters. As with the last problem, the focal length is 1/2 the radius of curvature, so 1/2 of the 40 is 20 centimeters. That's how far it is from the pink focal point to the lens, or to the mirror. Alright, in this case, like in the last case, I will use a candle as my object, and this little squiggly part at the top here is a flame. It's giving off light. Once again, if it was not a luminous object, it would need to have some light reflecting off of it from all parts of it, not just the top part, but the middle part and the bottom part. But all you need to do is focus on the top part of the object to locate the image. Light is given off in many different directions, but in particular, one of the most useful rays of light that comes off an object is the one that comes in parallel to the principal axis. That's almost always the easiest one to start with. That's step 1 in the definitions I gave you yesterday or today in class. Anyway, that ray of light reflects off through the focal point. Alright, that's the step 1 in ray tracing. Step 2 is a ray that comes from the focal point, in other words, lines up with the focal point, goes through or lines up with the object point, hits the mirror, that bounces off parallel. So that's the opposite of number 1. That's step number 2 in ray tracing. If we can draw those two rays, you can't always draw both of those. Ray number 1 you can almost always draw. You can't always draw that one. Ray number 2 sometimes is difficult to draw, as you'll see in example number 3. But anyways, those two rays to the left here are diverging. But if you extend them backwards with dashed lines, they have a virtual intersection back in this spot right here. Let me use blue to indicate their intersection. That's where the image position will be for the flame, because we started with the flame of the candle with our two rays of light. So where they converge again is where the image of the flame will be. Now from this and from experience, the flame will be up here, and the bottom of the candle always will lie on the principal axis, so the candle is going to look something like this. It's kind of like in a flat mirror where you have the image behind the mirror, but in this case it will be enlarged, and it's a virtual image. Virtual images are always upright. Alright, and you can also see here that I skipped step 3. I'll use a blue ray for that one, because this is optional. You do not need to draw all 3 of the special rays, but the third ray would have been the ray that passes through the center of curvature, goes through my object point, which is the flame of the candle, hits the mirror and bounces straight back onto itself once again. That would be ray number 3. You only need to draw 2 of the 3 rays, but if I drew the third one here as optional, that one also, if you extend it backwards, intersects to that same image point. Once again, verifying that is indeed the image location of the flame of the candle. That's not where the actual candle is, that's the image of the candle. It's behind the mirror. Alright, so now let's do the calculation for this. Once again, the formula, the main equation you'll be using is 1 over F equals 1 over P plus 1 over Q. We were given F to be 20 equals 1 over 10 plus 1 over Q. If you do the math here, you end up with Q equals negative 20 centimeters. That tells us a lot about the image. That's the image location. When it's negative like that for a mirror, it means it's behind the mirror, kind of like with the flat mirrors. It also indicates, let me go through the steps A, B, and C. It also indicates A, that it's virtual. It's a virtual image. You can see that in a diagram because it's upright and it's figured out or determined by extending the diverging rays to the left, extending them backwards by dashed lines to the right. The light does not actually converge at the flame or any part on the image. It just virtually converges. But once again, the other clue is that the Q comes out negative. So part B is, in fact, Q equals -20, the location behind the mirror. And then part C, what is the magnification? Magnification is negative Q, so it's -20, or the opposite of Q, that is, over P, which was 10. So the magnification here, there would be no units, they would be both centimeters, they'd cancel out, it's a ratio, gives you a +2. And a positive means it's upright and 2 times larger than the object. So that describes, mathematically, the 3 main characteristics of the image. It's virtual, it's located at 20 centimeters behind the mirror, and it's twice the size of the object.